Centuries before anyone heard of quantum, a Greek thinker named Democritus imagined matter as tiny, uncuttable bits, atoms bumping in a void, each shape giving us flavor and color. Around 430 BCE, he sketched the first outline of what we now call quantum thinking, not with equations, but with bold imagination. Fast forward to medieval Europe, where alchemists in candlelit labs heated strange powders and watched metals transform. Their notebooks brimmed with experimental details, distillations, crystallizations, the very roots of our scientific method. Those early chemists charted the first data logs, centuries ahead of Planck's blackbody experiments. But the real spark came in 1900, when Max Planck proposed that electromagnetic energy is exchanged in discrete chunks, quanta, giving birth to econ. Yet Planck himself acknowledged his debt to others. He built on Kirchhoff's work on blackbody radiation and Boltzmann's statistical mechanics. This wasn't a solitary bolt of genius, it was a flash ignited by countless minds. Meanwhile, half a world away, Buddhist scholars had long explored impermanence and interdependence. A 2023 study found striking parallels between Buddhist ideas of no self and the quantum observer effect, showing how observation shapes reality. In India, Vedanta philosophers spoke of an underlying unity, a web of consciousness remarkably like quantum entanglement. Pause and consider, if these ancient insights ring true, does it make sense to think quantum theory emerged in a vacuum? If you feel the universe is more entwined than textbooks suggest, tap that like button now. Back in the 17th century, Paracelsus and Agrippa mixed mystical belief with systematic trial. They discovered phosphorus and new acids, hard data that shattered Aristotelian dogma. Their alchemical logs read like proto-lab reports, foreshadowing how scientists today record each measurement with painstaking precision. Think of Marie Curie isolating radium in dusty Polish basements, knowing each decay event echoed back to Democritus's bold atom. In 1902, her papers measured radioactivity in counts per second, introducing yet another discrete process to physics. Those data gave later physicists the courage to trust quanta. Now imagine a Zen monk contemplating emptiness in 12th century Japan, unknowingly mirroring Heisenberg's 1927 uncertainty principle. The monk's koan pointed to the impossibility of fixed reality, just as Heisenberg's equations proved you cannot pin down both position and momentum precisely. Every time a particle detector clicks, that ancient question reverberates: does the act of looking change what's there? It did for Planck's oscillators, for Einstein's photons, for Schrödinger's waves, and it did for those who first pondered void and form. If you agree that quantum physics is the fruit of ages, not a single moment, drop a like. By the 1920s, Einstein was challenging even Planck, calling photons light quanta and arguing that energy comes in packets when light strikes metal. His 1905 photoelectric paper measured electron ejection rates in currents per microampere, hard numbers that demanded a new physics. Behind every equation lies a trail of experiments: Stefan's law on blackbody radiation, Rayleigh's law on scattering, Fowler's curves on emission. Each dataset added a stitch to the quantum quilt. And today, when physicists entangle particles across kilometers, they stand on the shoulders of Democritus's vision, alchemists' notebooks, and Eastern sages' metaphors. Quantum physics grew from ancient dreams and meticulous measurements, woven by many, not one. If this story moved you, share it with friends who love mysteries of the universe. Subscribe to Universal Insights for more journeys through time and thought. Comment below with the idea that surprised you most. Was it the atomists, the alchemists, or the monks? Let's keep this conversation alive.